Okay, good afternoon. Okay, today we will continue with chapter number 4 on radio transmitters. Since the chapter is a bit long, we will be covering for 2 weeks, so which will be around 4 to 5 parts. Okay, so today we will start with part number 1. Okay, so the outline of the chapter will be covering what is a transmitter. Okay, so we will learn what transmitter about, then the classification of transmitters, okay, different types of transmitters, then amplitude modulation transmitters. So what are the parts that involve inside? So we'll be looking especially on the constructions of the electronics. Okay, and we also will be looking on the frequency modulation transmitters, and what are the difference between the other types of transmitters. Okay, and the last part of this chapter will be on impedance matching network. Okay, so for this week we will be covering the first four parts. Okay, 1, 2, 3, and 4, and next week we will be covering on the fifth part on the impedance matching network. Okay, so the lecture note that I have given, so we'll be covering for this week. Part 2 will be covering for next week. Okay, so let us start with the first part. What is transmitter? Okay, this is basic block diagram of communication system. So usually the communication system, we know it will have a information, okay, information source, which you provide using the input transducers. So information source, like let's say your speech, so that is your information, you are saying something, so it will be captured by the input transducers, like microphone. It will capture whatever you are saying. It will pass to the transmitters, and the transmitters will pass the information to receiver through a channel. It will pass through a channel, reach the receiver. Then you will have output transducers. So for example, speaker, and you can hear whatever information passed from the beginning. Okay, it will be the output signal. So this is the basic block diagram of a communication system. Okay, so if you see, for a communication to be effective, transmitter and receiver plays a very big role. Okay, especially when you want to transmit for a far distance. Okay, so transmitters, so again, the information or the message is passed to a transducers. It will be changed. The information will be in the electrical form. Okay, before it passed to the transmitter, it will be converted into electronic form. Okay, so it take the information to be communicated in the electrical form. So meaning whatever, so let's say the speech you are giving to the microphone. Okay, so the microphone will receive in the electrical signal, and it will convert it. So with the microphone, you'll have an electronic circuit, which will convert the electrical to electronic signal compatible for the communication. So meaning there will be a conversion happening in between the transducer and the transmitter. Okay, so you need to change. So you cannot transmit an electrical signal directly to the receiver. Okay, so you need to convert it first. So that's why electrical and electronics are like brothers, two brothers. Okay, so they are like brothers, so they will be always working together. So you cannot totally rely on electrical without having electronics, and you cannot rely on electronics without having electrical. So for example, your laptop, so you need to have electrical power. If not, you cannot sustain for a long period. So you need to work along. So in this transmission process, the conversion between electrical and electronic, and at the receiver end, electronic to electrical, will be happening in order to have a effective communication. Okay, so in this block diagram, of communication system, The upper section is called the transmitting section. Okay, so you have two parts. Okay, this is your first part. It start with microphone. So you have a modulator. Okay, so there's some typo here. So modulator, then it will be transmitted. Uh, Before transmitting, it will be amplified and sent to the antenna. So antenna will send out the signal. So this is your transmitting section. Okay, so the section involved in transmission. Then once you send the information, so you'll have a receiving antenna. Receiving antenna will receive the information from the transmitting section. It will receive here. It will amplify, demodulate, and it will further audio amplify so that you can hear through your loudspeaker. So this will be your receiving section. Okay, so it will have two sections which will be responsible for the communication to happen. Okay, so we will see some parts of the transmission process. So the main parts of transmitter are explained as follows. I think mostly we already covered in the previous chapter, but just to refresh your knowledge. So microphone. So what it do? It will convert the sound into electrical signal in wires. So it is opposite of the loudspeaker. So loudspeaker, it will convert the electrical signal to sound, but microphone, it converts sound to electrical. Okay, so this is your first part. So this is the symbol for microphone. Then you have a modulator. So we have seen in chapter 2 and 3 how modulation works. So the audio signal is modulated into radio frequency carrier in this modulator stage. Okay, so we know in modulation, you'll have a carrier signal. So you attach your signal together so that you can transmit from one place to another place. So that is how modulation works. Okay, then we have a frequency generator. Okay, so what frequency generator will do? The frequency generation stage will decide the frequency on which the transmitter will operate. Okay, so for example, let's say you are using a FM. Okay, frequency modulation. So you must have a certain frequency that you set. So let's say 93.5. So that is the frequency that you want to transmit. So you'll use this frequency generator to decide the frequency, okay, for the transmission to happen. Okay, so when you are transmitting, so transmitting end and the receiving end must have the same frequency. If not, you cannot communicate. So you cannot expect the transmission and transmitting section to have 93.5, but the receiving end is using 105.0, let's say. So you cannot communicate. It's like dog is talking to cat. So you cannot communicate. So you must have the same frequency in both ends so that the communication can be transferred. Okay, so that's the function of frequency generator. Okay, then the fourth one is the radio frequency power amplifier. So you have a power amplifier here. Okay, so what the power amplifier? So we know amplifier means it will increase the gain. Okay, so the power amplification of the radio signal is carried out in the final stage. It makes the signal stronger so that it can be transmitted through the channel over long distance. We know when you are transmitting over a distance, after some time, due to the frictions, okay, the frictions can be even in wireless, it can have frictions. So even in the wireless, it can have interference, which will make the signal become weaker. So you need to have a amplifier, power amplifier, to amplify the signal so that the signal will become stronger, so that it can be communicated over a long distance. Okay, so that's the function of power amplifier. Okay, then the final part is the antenna. So antenna is a transducer which convert the electrical signals into electromagnetic wave. So here you have electrical and also electronic signal. So once it reaches the antenna, it will convert this electrical signal or electronic signal into electromagnetic wave. So we know electromagnetic waves, it has a various spectrum. So we will use that spectrum to transmit the information. Okay, so antenna is very powerful. So antenna can be used, I think we have seen in the previous chapters. So it can be used uh, to transmit and receive in a shorter distance, maybe between buildings, or it can be between different states. So it can be between different countries. So it can be even in with Earth and also outer space, like International Space Station or the satellite communication. So it will use a different kind of antennas, and we also have a military kind of antennas, and we can now transmit signal to the planet Mars. Okay, so maybe in future it can be even longer. Okay, so antenna can serve different applications. Okay, so basic block of transmitter. Okay, so it will consist of a modulator. So modulator will in charge for modulation to happen, and we have a RF, radio frequency oscillator. So oscillator is a electronic device that will generate the carrier frequency. Okay, so previously we have seen in AM and also FM how the carrier frequency will be a standard frequency, and you attach the message together with the carrier frequency. But maybe you have the question how the carrier frequency is generated. So carrier frequency is generated by a radio frequency oscillator. So that's why the signal is like an oscillating wave, okay, like a sine wave. Okay, so radio frequency oscillator will create that. Then we will have a power amplifier. So power amplifier we have seen previously. So it will provide an amplification of the power or the gain of the signal. Okay, so that it can be used to travel, uh, transmitted in a long distance. Okay, so we're still covering the basic functions of transmitter. It is an electronic unit which accept the information signal to be transmitted and converts it into an RF signal capable of being transmitted over a long distance. Okay, this on the transmitter side. So it's actually you don't buy separately and assemble. It's already coming as a one unit. Usually, when you buy a transmitter from, so let's say in your car, so you left the radio. So it is considered a transmitter because it's already have all the unit we discuss here inside. Okay, until the antenna usually will be on top of the car. Okay, but all these parts is already available inside. Okay, so maybe in the car it's not the transmitting side, it's receiving side, because we don't have a microphone. So microphone usually will be in the radio station, but we usually will have this in the car. So we'll have the amplifier inside. So if you don't have a specific amplifier, so you might have the inbuilt amplifier in the radio already. So you have a demodulator and audio amplifier and also the loudspeaker attached to the car, and the antenna will be on the roof of the car. Okay. Okay, so the basic function of transmitter, so it will accept the information signal to be transmitted and convert it into radio frequency signal for transmission. Okay. Okay, every transmitter has three block basic function as follows. Okay, there are three basic function. Okay, the transmitter must generate a signal of a correct frequency at a desired point in the spectrum. So because we know radio frequency spectrum, it can operate over a very big range. Okay, so you need to select a certain frequency that you want to transmit, and you need to generate the signal according to that frequency. Okay, so that's very important. So that's the function of the transmitter. Then secondly, it must provide some form of modulation. Okay, earlier we have seen. So you have an oscillator to create the frequency. Then you have a modulator. So a modulator, what it will do, it will modulate the carrier frequency, and it will combine together with the message that you want to submit. Okay. Then the third one, it must provide sufficient power amplification. Okay, in order to carry the modulated signal over the long distance. Okay, so it must have the power amplification in that process. Because once, so let's say you only focusing on creating the carrier signal and also modulation, but you fail to do the amplification, so maybe it cannot really reach the other part that you want to transmit, because not enough power. Uh, so it's like you didn't eat for so long, and suddenly you need to run 100 kilometers. Cannot. You must have the power. You need to do the practice. So power amplification is very sufficient for the transmission. Okay, so that's on the first part. Okay, about the transmitter. So what a transmitter about? Then we will enter the second part, the classification of radio transmitters. Okay, so how radio transmitters are classified. Okay, so we will see here different types of radio transmitters. So usually radio transmitters will be classified using this criteria. So usually the first class will be according to the type of modulation used. So are you do you want the radio transmitter to only use FAM, okay, amplitude modulation, or you want it to have only FM, or you want it to have both, or you want to have other type of modulation? So you choose your radio transmitters based on the modulation type. So when you want to buy a radio transmitter, make sure you know what type of modulation you want to buy. So if not, because nowadays we buy everything from Shopee or Lazada, so we go and check. So in the picture, it look very big, or it look very fancy, but if you didn't read the description properly and the size, so usually at the end they will mention the size. So maybe in the picture it look like very big, but in the dimension it's actually small. So we cannot buy like that. Okay, so make sure when you buy a radio transmitter, you read the specification properly. So whether it's within the operating frequency, so is it using the type of modulation that you want? Because usually the radio transmitters are not really cheap. Okay, even though it's affordable, but you don't want to waste your money, right? So make sure you buy according to the correct classification. So the first classification is based on the modulation type. The second one is the service involved. Okay, so where you want to use it. Okay, so if you want to use it for a specific application, and you want to provide a service, then make sure you select it according to the service or the application that you want to use. Okay, so we don't want. So let's say you want to communicate. So I just give an example. You want to talk to alien. So you don't buy a transmitter that only can transmit between your house to the neighboring house. So you need to have something that can communicate with the outer space. So that is what I call as application. So where you want to apply it. So you need to make sure that then you select your radio transmitter. Okay, the third one, according to the frequency range involved. Okay, so what are the frequency range? Because we know amplitude modulation will have a different frequency. So later we will see where there are some slides on that. So we need to make sure we need to decide which frequency range we want to use, and we need to select the radio transmitter according to that. Okay, so that's the third one, and the fourth classification is according to the power use. So power, it determine how far you want to transmit. Okay, let's say from here you want to transmit to Kanga, so maybe you can use a uh, normal power uh, transmitter, radio transmitter. But if you, let's say, you want to transmit from here to Kuala Lumpur, so you need to have a better radio transmitter, because the distance from here to Kuala Lumpur is almost 500 kilometers, and the geography, in between you have mountains, so you have uh, different different landscape, so you don't want any transmission loss in between. So you need to have proper power so that it can withstand and it can go above all these obstacles. Okay, so these are the four types of classification of radio transmitters. Okay, so classification based on the transmitted frequency. So earlier the third part, the frequency range. So we can see the transmitter. So we have a low frequency transmitters, or we call it as a LF. LF. So it will operate between 30 kilohertz to 300 kilohertz. Okay, 30 kilohertz to 300 kilohertz. Then we have a medium frequency MF transmitters. So this is between 300 kilohertz to 3 megahertz. And we have high frequency HF. Okay, so mostly now we are using this HF. Okay, so HF also we have a different kind of high frequency. Okay, so it will be between 3 megahertz to
Hello.
yes, yes. Anything? Okay, so high frequency, it will be operating between 3 megahertz to 30 megahertz. Okay, so if you further divide this high frequency, so we can, I think maybe you have heard all these terms. VHF, very high frequency. So earlier it is until 30 megahertz. So we have a very high frequency, so which will be covering 30 megahertz until 300 megahertz. So we call it as a VHF. And we have a UHF, ultra high frequency transmitters, which can cover 300 megahertz to 3 gigahertz. So there are various types of frequency, transmitted frequency, that we can classify. Then now is quite common, microwave transmitters. So we have a microwave transmitter which can cover more than 3 gigahertz of frequency. Yes, so as I say, the radio frequency spectrum is very large. So you need to decide which spectrum you want to use, which frequency range. And when you want to buy the radio transmitter, make sure it follow the frequency range that you want to use. Okay, so don't later on you want to do a project, so you're supposed to use a UHF, but you mistakenly buy a radio transmitter with VHF. So let's say the frequency that you want to use is 400 megahertz. So this is cannot cater to 400 megahertz. The maximum is only 300 megahertz, so you cannot use. So it's very important for you to understand how to choose. Okay, and classification based on the type of service involved. Okay, so type of service, as I say earlier, um, where you want to use, which application you want to use. So it is very important. Okay, so radio broadcast transmitters. Okay, so radio broadcast, so usually like used for broadcasting. So it can be even related to TV. or it can be related to the transmitter in your car. So you can go long range. Okay, long range. So let's say from Astro. So Astro is in Selangor. So you want to transfer to Perlis. So you need to have a long range FM broadcast transmitter. So transmitter usually will be attached there. We will have a receiver in the car. Okay, so radio broadcast transmitter. So this is the example. So between cities, okay, between cities. But now we have more advanced technologies where we use Internet of Things. Okay, so this radio transmission is connected to internet. Okay, so you're sending this transmission to the internet session. So you have a digital modulation which will be converted into internet signal. So you can connect your receiver to the internet as well, and you can hear various of stations from the world. So you don't need to be within the range also now, because internet, it has a very is actually a better gateway, okay, or better backbone. We call it as a backbone in network. So which can connect a lot of things. Okay, so we as engineer, we can always innovate in order to make things better. Okay, so that's the first one. The second one is a radio telephony transmitters. So we always will see it like this. Okay, so for radio phones, telephone. Okay, for telephone. This like DG, Cellcom, Maxis. So all usually there will be a tall tower with all these antennas. So different telco will have a different antenna attached to it. So usually the telcos will share the money to build the tower, and they will be attaching all these antenna to the tower. Okay, and some of the companies, they even rent out or lease out their antennas like Cellcom. So usually, let's say you are using let's say TuneTalk, other telcos like TuneTalk or UMobile. So usually they will be using Cellcom infrastructure. So they will be paying instead of they go and install another antenna in the same tower. They will just use the existing antenna and they share the cost with Cellcom. Okay, so uh, because when you have too many antennas, there can be interference as well. Okay, so they want to reduce all that aspects. So we have radio telephony transmitters attached to this. Then we have radio telegraph transmitters. So this is a telegraph machine. So telegraph machine was used before telephones were invented back then. So especially during this World War One, World War Two. So telegraphs and Morse codes are the common communication. Okay, so usually this telegraph key, so it will be attached to the electronics. So it will have a battery and turning coil and everything. So it will be connected to the uh, transmission line. It's wired. It's not wireless. It's wired. So you use this telegraph key to send signal. Okay, let's say A. So you press once. Okay, I just give an example. Press one. So B, you press two times. So if you want to have space, so you press for a longer period. So at the receiving end, another person will be jotting down the signal, and they will interpret accordingly. So it was used in the military during World War One and Two to send information between stations, between countries. Okay, so this is a radio telegraph transmitters, but now we are not really using this already. Okay, so it's already outdated and obsolete. You cannot even I cannot even find a proper picture for the telegraph machine. Okay, because it has a it's already uh, uh, more than 100 years old technology. Okay, but it's only for your understanding. Then we have television transmitters. Okay, so this is for the television. Usually we can see above the eels, okay, tall eels, okay. So with great height, so they will place the television transmitters, okay, so that it can cater the area around. Then we have radar transmitters. Okay, so radar transmitters. So usually we can use for military. Okay, so now the radar transmitters are uh, very high technology. So so I think you will be following the war technologies as well. So you can see how they keep on making things better, but I don't know for what, because it's all lead to destruction. But maybe in terms of like protection for the country. So radar transmitters are useful to prevent intruders. Okay, to use our airspace. Okay, so because anytime that any attacks can happen. Okay, so it's quite useful and important technology. And we have a navigational transmitters. So navigational transmitters usually will be on the transportation, like ships. So used for navigation. So it will be a smaller type of antenna, but it's quite powerful also to uh, transmit informations. Okay, so this is on the ship. So even we have a navigational transmitters on the aircrafts, okay, where we can communicate. Okay, so different applications, it has a different constructions of transmitters. Okay, transmitters and also receivers. Okay, so it's very important. So you cannot use a television transmitter for radar transmission, and you cannot use a navigational transmitter for television transmitters. So it might not fit the purpose. Okay, so you need to select the correct transmitter for the correct application. Okay, then classification based on types of modulation. Okay, so you have a complete wave transmitters. So now we can even have a small circuit for you to transmit. Okay, transmit a full cycle transmission, okay, for your projects or whatever. So you can use this kind of transmitters, electronics, for your projects. So we have AM transmitters. So I believe you have seen this in your car. So attached to uh, the smoke pot. Okay, so you attach this. So then you can just tune it according to the frequency. So usually it will become coming together with AM also and also FM. Even though FM is the one that we use more, because FM is more stable. Uh, AM we know it has a weakness, so interference can happen and it can alter the message. So by AM is more stable. So we usually will have this, and we will tune it in the frequency range where we want to listen to our favorite transmission station. Okay, and we know SSB, a single sideband transmitters. So we have seen in the previous chapters how single sideband it is a very complex process. So first you are removing one part of the sideband, then you are removing, you are only maintaining only one, and it become a single sideband transmitter. So it's actually involve a lot of electronics inside in order to make it a single sideband. So that's why it's more in a, it's not a small electronics like this, but it's a bigger version. It's more like a equipment, okay, for transmission. Okay, so these are based on the modulation type. Okay, so modulation type we can you choose our transmitters. Okay, so third part, So we will see some part of AM transmitters. Okay, so AM transmitters, involve also power amplifier and AM modulation techniques. So AM modulation technique is used in AM transmitters. So of course, the transmitter is using the amplitude modulation. So amplitude modulation, we know, is it having a carrier signal, and you have a signal, your message signal with the amplitude. So when you combine together in the modulation, the modulated signal will follow the waveform of your message. Okay, so that's why we call it as an amplitude. So when the amplitude is higher, so the modulator signal also will be higher. Okay, so it will based on the proportion of the amplitude of the modulating signal, and it will keep the frequency and pace constant. Okay, so usually we will use these AM transmitters in radio and TV broadcasting. So we can see, but nowadays we are not really using this already. Maybe 20 years back, yes. So we have a different kind of antenna on top of our house. So maybe you have seen also at that time. So we always it will be like a rod kind of antenna on the roof of our house. Now we are mostly using this Astro kind of uh, transmitter and receivers. Okay, the antenna. Okay. Okay, so AM transmitter. So AM signal is transmitted by the transmitter. So the information is contained in amplitude variation. So when the amplitude is varying, so the information is stored in between. Okay, so this is a circuit. Usually the circuit will be like this. So you have a crystal to generate the carrier frequency. Then you have a BJT, uh, BJT circuits. Okay, in order to create the modulations. Okay, and you have a aerial here. Okay, so AM transmitters. Okay, the oscillator will generate the oscillation or the carrier frequency. Okay, so carrier frequency will be like this. Okay, so usually we will use a crystal oscillator. Okay, so primarily we will use this in AM transmitters. So crystal oscillator will create a carrier frequency. Okay, then we have a power amplifier. So let's say initially it's only 2 bar. So I think if you see this bar, you will understand better, because now we will look at this for our phone and also internet especially. So we know if only 2 bars is not strong, signal is not strong. So when it goes through power amplifier, so from 2 bar it will become 5 bar. So that is the power of amplification. Okay, so amplifier will increase the gain of the overall circuit. Okay, so there are various types of classes, class A, B, and C for the power amplifier. So all these amplifiers are basically bipolar junction transistors, okay, BJT transistors. So here also we have seen, so you have BJT here and also BJT here. So all that are the power amplifiers. Okay, so the AM transmitters. Okay, so for class A, so let's say this is your signal. So it will send everything. So uses entire input signal. So let's say your input signal is like this. So it will take everything and use it in your circuit. So because it's taking everything, so maybe not all the message are useful, and because of that, it is low. It's having a low efficiency. Okay, and class B is only taking the positive side. The negative side is just remove. So we only use 50% of the input signal, and the efficiency is between 78 to 79%. Because maybe the part that it throws. So there can be some useful information also. So that's why the efficiency is about 78 to 79. So low efficiency here meaning it can be less than 50. Okay. And we have a class C. Class C is only taking a certain portion which is useful. So it will have class C. Normally it will have a mechanism to select crucial information, and it will only select. So maybe it will only select this side or maybe this side. If it depends on where the information lies. Okay, so and because it's only taking where the informations are, so the efficiency is higher. So almost like 90%. So still 10%, there are some losses involved. Okay, so I think so I only cover until here for today. So we will be covering the rest for tomorrow. Any questions so far from today's slide? I don't want to cover a lot, so we just go slow. So any questions? Anything that you want to ask?
Sir,
Yes.
what is the difference between electrical signal and electronic signal?
Okay, so please hold down. Okay. Okay, so this slide. Okay, so if you see, so you are passing the information. So information is passed here to the transducers. So the information is converted into electrical form, and before it's transmitted, it must be converted into electronic form. So it takes the information to be communicated in electrical form. So when I show from this part. Okay, when you are using the microphone, so microphone you are giving your speech. You are talking to the microphone. So when you are talking, so it is your it's an analog signal. It's an acoustic signal. Acoustic means it's your voice. Voice is your signal. It's an acoustic signal. It's entering the microphone. So microphone, what it does, it converts the sound into electrical signal in the wire, because the microphone is connected to the wire. Okay. So in order for you to, let's say you are speaking. So I am saying A. So A must be converted to electrical signal, maybe between 0 to 5 volt, or maybe A is 3.5 volt. Okay, so that is how acoustical signal is converted to electrical signal. So electrical signal usually will be measured in volt. Okay, then it will be modulated. Modulation is still electrical signal. Then you will have a frequency generator. Once it enters the RF amplifier, so you cannot give electrical signal to radio frequency amplifier. Okay, so you need to use electronics, because in the amplifier, so it will receive the electrical signal. So electrical signal, it cannot be transmitted to electronic wave. So you need to convert it into electronic signal. See, electronic signal meaning it will use electronics like the one that we have seen earlier. All these are electronics. All these are electronics like resistors. So you have a BJT. So you have a crystals. So all these are electronics. So usually, if you let's say you're opening an electrical device. So let's say you open your laptop. So inside you can see electrical parts. So which maybe is connected to your cable, your charging cable. So charging cable is 240 volt, right? So it will be connected to maybe to your battery. So from the battery, the output will be 5 volt. 5 volt, which will be powering this electronic board. So electronic board usually you cannot operate with 240 volt. It only can operate with a lower volt. So usually the lower volt will be electronics. So like here is only 6 volt. So let's say you are using your mobile phone. So mobile phone, even though we are charging the mobile phone using 240 volt, okay, the charger is connected to 240 volt. So inside the charger, so you have electronics which can convert electrical 240 volt to maybe 5 volt, 5 volt or maybe 3 something volt or 2 volt, depending on your phone. And this 2 volt will enter to your phone. So inside your phone, there are no electrical component. So you're only having electronics component inside. So what will happen if 240 volt you give direct to your electronics, your phone? What will happen? Maybe you can answer.
Damage. The phone will be
So it
damaged.
will damage. So electronics and electrical must work together. So at the same time, when you are dealing with electrical appliances, so you cannot use electronics to power it. So you cannot use your power bank to start to operate your fan. Cannot, because power bank the output is only 5 volt. You need for your fan you need 240 volt. So either you give this 5 volt, you use a transformer to convert the 5 volt to 240 volt. So the transformer is the electrical component, so which will become a bridge between electrical and also electronic. So in this transmitter, so both electronics and electrical must work together in order to have a proper communications. So at the same time, when this conversion happens, so you cannot afford any information loss. So that's your job as an engineer. So you must protect all the equipment and your electronics. At the same time, you need to ensure the communication is not distorted. So meaning if you say A, your receiving end must receive A. So in between the conversion, you cannot have any signal changes. So all these are very important in this aspect. Okay, did I answer your question?
Yes, doctor. Thank you.
Okay. So any other question? So we have 10 minutes. No question? Okay, so if no question, please hold on.